Hello everyone. In the previous video, we have done DC circuit, its basics and its types. In this particular video, we will be discussing the elements of DC circuits which are used in DC circuits. So on the screen, you are seeing there are basically three categories of DC element circuits. The first one is active and passive elements, then is it can be categorized as linear and non-linear elements, and then the third category is unilateral and bilateral elements. This video will be a brief session about the introduction of these elements, and we will go into a little detail of the series and parallel combinations of resistors, capacitors and inductors. Along with this, we will take a view of glimpse of definitions of the inductors, capacitors, and other voltage and other types of sources. So let us start. So today's topic is elements used in DC circuits. So there are three categories basically. Number one is they can be divided into active and passive elements. Number two is they can be unilateral and bilateral devices, and they can be linear and non-linear elements. So let us start with the first category, which is active and passive elements. So what are active elements? Those elements which can generate energy or which can acquire energy from a system, from a DC circuit. They can either give energy or either they can consume energy from the system. So they can also be defined as those elements which require some external energy source for their operation. These can also be categorized as active elements. So active elements are those which require external energy for their operation, or they can supply or consume energy from the circuit. They can consume energy from the circuit. Now, with the help of examples, we can very quickly understand what does that mean. So, the best example is voltage sources or current sources. Voltage sources or current sources, or these can be diodes or transistors, bipolar junction transistors. Now, the second one is passive elements. So, dear students, passive elements are those which do not require any energy for their operation, any energy for their basic operation. So the example is resistor. The best example is resistor. The second example is inductor, and third one is capacitor. So what does that mean? They do not require any energy for their operation. Let us take the example of resistor. So resistor is any element which only opposes the flow of current flowing through itself. So its only duty is to oppose the flow of current within the circuit. That means it does not require any kind of external source for its own operation. We just place it in the circuit in series or parallel combination, and it obeys its duty irrespective whether any external supply has been given to this particular element or not. Similar is the case for inductors and capacitors. On the other hand, however, if we use diode as a clipper, we have to bias the diode for a particular value of voltage. Then it can perform the action of clipping the voltage or current. Otherwise, it will not perform. So this is the basic difference between active and passive elements. So active elements are voltage sources, current sources, diodes and transistor, and passive elements are resistors, inductors and capacitors. So we can study these on the presentation slides. So let us start with that. So these were the three categories: active and passive elements, linear and nonlinear elements, unilateral and bilateral elements. We have discussed the basics of active and passive elements. Now let us discuss the basics of linear and nonlinear elements. So what are linear and nonlinear elements? Let us start with this. So the second category was linear and non-linear elements. So linear means which perform their operation in a linear manner. Linear manner means, let us say this is a resistor, for example. We have applied a voltage to this, and let us assume this voltage is variable. That means we can increase or decrease this voltage, and this is the value of resistor. What will happen if we plot the graph between its voltage and current, its applied voltage and current? What will happen? Let us say the voltage, we are taking this only for example. Let us say the graph has been divided like this in this kind of values: 0 ampere, 1 ampere, 2 ampere, 3 ampere, 4 ampere. Although the current and the voltage will not be same as that of when we perform these experiments practically. Let us say the voltage is 1 volt, 2 volt, 3 volt, 4 volt, 5 volt, 6 volt, let us say. Now if we increase the value of voltage, let us say the first reading we take it at 1 ampere, the current will be 1 ampere. We are only assuming this, and this will always not be true, because we are just understanding what is a linear device and what is a non-linear device or element. So if we increase the voltage to 2 ampere, 2 volts, the current now will be 2 amperes. For similarly for the 3 volt, the current will be 3 ampere, and this process will continue. Now the graph obtained will be linear. Linear means straight line. It will be a straight line. So the graph between applied voltage and the current will be a straight line in case of linear elements. So linear elements are those whose operation is linear. On the other hand, non-linear devices are those, let us say this is an inductor or capacitor, and we have connected a variable DC supply. The graph will not be same. Let us say this is V, this is I, the applied voltage and current, which can be controlled by ourselves. So the graph can be like this. It will not be linear. Or in case we have connected a diode in a circuit and we have applied a voltage, and then if we plot the graph between V and I, the graph will not be the linear, always it will not be linear. So this is the difference. These are the characteristics of linear devices, and these are the characteristics of non-linear devices or elements. The examples are: the linear element which we commonly use is resistor, and non-linear elements can be capacitors, inductors, diodes, transistor. All these are non-linear elements. Okay. Now the third category is unilateral and bilateral devices. Unilateral and bilateral devices. So let us start with this. The third category is unilateral and bilateral devices or elements. So what are unilateral? Uni means one. That means they can perform only in a single direction. For example, if we are having a diode, let us say, and we apply a voltage in this direction, positive is connected to P type and negative is connected to N type, then only it will conduct. Now if we reverse the direction of applied voltage, negative is connected to P type and positive terminal of the battery is connected to N type. What will happen? It will now not conduct. So that means its operation changes whenever we change the direction of applied voltage. Such kind of devices are known as unilateral devices whose operation remains same only from the one direction. And if we change the direction of the applied voltage or source or energy, its operation will also be affected. Now, what are bilateral devices? So bilateral devices are those irrespective of the direction of these devices, their operation remains same. For example, a resistor, capacitor, inductor. Doesn't matter if we connect, let us say this is a term AB. If I connect AB with the supply positive and negative, it will behave same when I reverse the direction of this element. So let us say if this resistor was of 5 ohms and if I reverse its direction, it will also oppose the current with the same energy, same potential, which is 5 ohm. Potential here means its quality to oppose the flow of current. So it will offer the same resistance, same hindrance. So these kind of devices are known as unilateral and bilateral devices. Now, let us move further. So this is the proper classification which you are getting on the screen. Further classification of DC circuit elements. So electronic components are usually divided into two parts, passive components and active components. Active components, as we studied, they are basically energy sources or diodes or transistors. So these are again of two types, electrical energy sources and semiconductors. Semiconductor devices are of two types. These are either diodes or transistors. Now, voltage sources are the electrical energy sources and current sources are also electrical energy sources. These can be subdivided into further categories. These can be ideal voltage source or practical voltage source. So current sources can also be ideal and practical. Practical voltage sources have further classification and practical current sources also have further classification, which we will discuss in the next presentation slides. Okay, now this is the turn for passive components. So passive components are resistors, capacitors and inductors. These can be fixed and variable. Inductors can be iron core or air core inductors. Let us move further. So these are the definitions. Number one is voltage source, a battery that provides the electricity for the circuit. A resistor, it is a passive component that regulates the flow of current and dissipates energy as heat. Inductors, used to introduce inductance. Inductance is the property by virtue of which inductors store magnetic field. They store energy in the form of magnetic field. Okay. Now, capacitors, they have the ability of storing electrical energy in the form of electrical field. So both of them have their own respective operations and are used for different purposes in the various DC circuits. These are the diagrams on your right hand side. This is the resistor and these are the color codings, which if required you can mention those things in the comments and we will have a separate video on those. This is the capacitor. This is the inductor, which is simply a coil or a wire which is wound in the form of a coil. These are the variable resistors whose value can be changed with a screwdriver, or you can rotate the knob on them and the value of the resistance can be changed. This is a transistor, bipolar junction transistor. This is the symbol of diode. These are light dependent resistors. These are integrated circuits or ICs, LEDs, transformers, switch and all the other electronic devices which are used in the DC circuits. So these are some terms which are associated with the DC circuit. Wire loop, a loop of wire that allows current to flow around. So let us say we are having a circuit. So let us say we are having a circuit in this manner. So this is a voltage source. and there is also a voltage source over here with the resistor. This is a resistor. So this is one loop, this is another loop. So these are the two loops, loop L1 and loop L2. So these are the two loops. Now a switch, a component that can be used to control the circuit, ammeter. Ammeter, we already know it is connected in series. Whenever we use ammeter, it is used to measure the current, and it is always connected in series. Voltmeter, it is a component that measures the voltage in the circuit, and it is always connected in parallel. It is always connected in parallel. I can show this by making a simple circuit over here. Let us say this is a resistor and there is a voltage which is supplied over here. If we want to know what value of voltage is being fed across the resistor, we can connect a voltmeter in parallel. If we want to check what is the current flowing in the circuit, we can connect an ammeter in the series, and it will measure the current, and voltmeter will measure the voltage. So these are the elements of electric circuit, and the first one is active elements, which are voltage source and current source. Passive elements, as we have already discussed, these are resistances, inductances, and capacitances. Now the sources are further categorized. As I discussed over here, there is further classification of the energy sources. So these are the classifications. So energy sources can also be practical energy sources, can be so practical energy sources can be independent or dependent. Independent are ideal and practical. Ideal and practical. Dependent are voltage controlled voltage source, voltage controlled current source, current controlled voltage source, and current controlled current source. Let us have a look on them. So when we are having a circular symbol for a voltage source, it is known as independent voltage source. Simply, if we want to use or we want to represent an independent voltage source, what we have to do is we have to draw a circle and a positive and negative mark. So this will be independent voltage source. Similarly, if we mark arrow between them within this circle, it will be a independent current source. Okay, so these are independent voltage sources, and this is the graph of ideal source. This is the ideal voltage source, ideal and independent. So in ideal voltage source, as we discussed in the first video, the voltage never dies out. It never comes to a decreasing value. But in practical scenario, there is always some kind of heat or dissipation of energy when we use some particular device for a particular amount of time. So practical sources have a fixed do not have fixed value of voltage for all the time we use it, the value eventually decreases. Similar is the case for ideal current source and ideal practical current source. So the current value also decrease with respect to time. Okay, so these are the symbols for voltage controlled voltage sources, current controlled current sources, current controlled voltage sources, and current controlled current sources. So this is voltage controlled voltage source. So voltage controlled means its output is dependent on some primary input. Now how this comes into play, let us say you are having a circuit and this is an independent voltage source V1. There is a resistor, there is also a resistor or load. There is another circuit in which we are having a dependent voltage source. Now this voltage source is dependent upon this voltage V1 with the constant K1 and V1, and this is a voltage source, so we will mention the symbols of plus and minus, which signifies it is a voltage source. Similarly, this can be replaced by this thing. So if we mark an arrow in between this particular rhombus type structure, so this will become a current source, but if it is dependent upon voltage, it will be known as voltage controlled current source. Similarly, there is current controlled. So here the constant value changes. It is dependent upon K3 I1, and the symbol between this square box is positive and negative. So that means it is a voltage source, but is dependent upon current. So it is a current controlled voltage source. Similarly, there is a current controlled current source. This arrow tells us. So I hope you would have understood these notations. So now this is the formal definition of resistor. It is the capacity of a material to resist the flow of current. So the units are ohms, the symbol is omega or ohm, and the prefixes can be kiloohms or megohms or simply ohms. These are the symbols of fixed resistors, variable resistor. Practically, if you find resistor, it will be in this form, and these are other types of resistors. So we have done this in the first video. The only difference over here is they have calculated the power, which is P is equal to I square R, and if we use the formula V is equal to IR and use the value of R from this, V upon I is V upon R, we will get power is equal to V square upon R. Similarly, work and energy can be calculated, and this is the series combination of resistors, and this is the parallel combination of resistances. So next is the term for inductor. So inductor is any component, any electrical DC or AC element in which energy is stored in the form of magnetic field. So whenever we know a current passes through an electric wire, there is always a generation of magnetic field. And if we wound this wire around a coil or just like a coil, it behaves as storage of strong magnetic field. So when the current passes, a strong magnetic field across this inductor is developed, or when this voltage is being changed, which has supplied this inductor the energy to generate the magnetic field, the same magnetic field opposes the change in the current due to the magnetic field produced according to Lenz's law, which is an advanced topic, and we can study it later on. So you can simply over here assume that inductors doesn't allow any change in their source, either it is voltage source or current source. If there is any change in the current supplied to the inductors, they always oppose the change due to the production of induced EMF. You have to remember this. So inductors does not allow AC to pass through them because they are offering the changes in the currents, and the changes are not accepted in the inductors. So simply we can assume if we apply DC current to the inductor, it will be very easy for that DC current to pass through the inductor. But if we apply AC current, it will follow a kind of hindrance or resistance, which is known as impedance from the inductor. So it is measured in Henry and symbol is H. So usually inductors are available in millihenry or microhenry. And the formulas associated with this are V is directly proportional to rate of change of current, which results in this formula V is equal to L di by dt. We can also derive the equation of current from this. V by L is equal to di by dt, or 1 by L V dt is equal to di. Integrating both the sides, it will be like this, and the formula becomes I is equal to 1 by L integration of V dt. So this is the formula for current associated with the inductor. This is the formula for voltage, and this is the formula for current. Okay, I hope this is clear. So these are the series and parallel combination of resistance inductors. So which we can do in the next video. So V is equal to LD by di by dt, voltage across the inductor. The energy stored is given by half Li square. We can derive this in the next video, but here you simply assume that it is a kind of inductor, and the total it is a kind of resistor, and similar to the resistors, the series combination of resistances are R1 plus R2. Similarly, series combination of inductor is L1 plus L2 plus up to Ln. Similarly, similar to the resistances, the parallel combination of resistances is given as R1 R2 by R1 plus R2, or 1 by R parallel is equal to 1 by R1 plus 1 by R2. So similarly, 1 by LP or the parallel combination of inductors acquire the same mathematical notations 1 by LP is equal to 1 by L1 plus 1 by L2 and so on up to the number of resistors used in the circuit. Third is the case for capacitors. So capacitors have ability of storing electrical energy in the form of electrical field. How they store? Let us say there are two plates of capacitor. This is the symbol of capacitor and it is having two placed polarized plates, positive plate let us say and negative plate. So what will happen when we apply a voltage to this? It stores energy, current flows and it stores positive charge over here, let us say, as we have connected a positive terminal to this end. And by electromagnetic induction, the another plate acquires opposite charge. It becomes negative to stabilize itself electrically. So when we connect this capacitor, this charged capacitor by somehow method to ground, by somehow method to ground, it will always get discharge. It will get discharge. So this capacitor will get discharge if we somehow connect it to ground. Okay, so the formulas associated with capacitors are I is equal to C dV by dt or V is equal to integral I dt 1 by C. Is that clear? So these are the formulas associated with the capacitors and the property by virtue of which it stores electrical energy is known as capacitance. It is measured in farads and the capacitors can be practically available in terms of microfarads and picofarads. So these were the three passive elements. The equivalence of these we can do of the resistances, capacitors and inductors. The equivalent circuit of series and parallel combination of resistors and capacitors and inductors, we can do this in the next video, although we have done the equivalent circuit of series and parallel combination of the resistances in the first video. So when capacitors are connected in parallel, the formula becomes C is equal to C1 plus C2 plus C3 plus up to Cn, unlike the inductors and resistors. So series combination of capacitors is 1 by C1 plus 1 by C2 . So the series combination acquires the form C1 C2 by C1 plus C2 or 1 by C series is equal to 1 by C1 plus 1 by C2. On the other hand, however, the parallel combination is simply addition of the two capacitances. So the formulas are I is equal to C dV by dt and work is given by or energy stored is given by half CB square. This is the series combination and this is the parallel combination and series combination. We can derive these in the next video. So now come to the advantages of circuit elements. Resistors, they can control the current flow. They can protect other elements from large current as it opposes the flow of heavy current. They provide regulation of voltage in the circuits. Now the applications or advantages of capacitors are these are efficient storage and they offer efficient storage and release of energy. Which energy? Electrical energy. So they store energy in the form of charge. So which energy is there? It is electrical energy. Now they can also filter out AC power supplies and audio signals because they allow AC alternating current to pass through themselves and does not allow DC to pass through themselves. So if a variable signal and a DC signal is present in a combined mixture of signals, complex signal, they can filter out easily the AC signal. So they also provide stability and response time in the circuits. Inductors, they have advantages of storing energy within a magnetic field. They also serve as means of cleaning high frequency noise in the power supply. Or the combination of inductors and capacitors can also be used as filters to remove noise from the signals. So these are some disadvantages. Inductors usually heat when they are used for a long time and maximum current is not always achieved. Capacitors, the storage of energy is limited depending on the capability of storing the electrical charge. Charge can also leak if they are not used over time. So inductors are, as they are being manufactured from the you can say the coil of wires, so they are bulky. So wires can also have resistor, internal resistance along with the inductance or the inductive impedance. So they can offer hindrance to the flow of current also. These are the disadvantages. So these are some applications. Resistors are used in potential dividers, current limiters, and biasing circuits. Capacitors are used for power supply smoothing, and I have also already said they are used as filters. And inductors are applicated in most of the transformers, filters also, and they are also used in radio frequency application. So this is all. In the next videos we will study Ohm's law, but before that we will solve the combination of parallel and series combination of inductors and capacitors. I hope you would understand what we have studied till now. In case of any doubts, you can have me the you can have me in your next videos with your doubts mentioning in the comment section. So that's all for today. Thank you very much.